Welcome to Math Minders Academy. So today we are continuing with the part 2 of modular arithmetic. If you have not watched the part 1 video, please go back to my channel and watch the part 1 video so that you will be able to follow through in this part 2. This part 2, we are going to be looking at typical examination questions. Here, we will be looking at questions that involve the use of table, as we have in this particular example. So now, this table, we are given a multiplication table in modulo 11. They say copy and complete the following table for multiplication modulo 11. Now we expect to have numbers less than 11. So here, part of the table has been completed. So let's see, we have this 1, 2, 3, 4, 5, 6, 7, 8, 9 empty boxes to complete. Now let's perform the multiplication in modulo 11. Here we do 5 times 5. 5 times 5 is 25. 5 times 5 is 25. Now, if we divide 25 by 11, it's going to give us 2 remainder 3. 11 can go in 22 twice, and then in 25, we have a remainder of 3. So here we enter 3. We do again 5 times 9, that gives us 45. If we divide 45 by 11, it gives us 4 remainder 1. We put the remainder here. 5 times 10 is 50. And how many times can 11 go in 50? 11 can go 4 times in 44. So we have a remainder of 6. We put it. Now we move to 9. This element 9, we use it to multiply all of these ones here. We are using it to multiply all these elements here. We are using these ones here to multiply the ones up. So here we have 9 times 5. 9 times 1 is already recorded here. So 9 times 5 is 45. Again, it will give us 4 remainder 1. 9 times 9, 81. Whereas 11 can go in 77. So it can go 7 times in 77. So in 81, we are going to have a remainder of 4. So it's going to be 7 in 81. In 81 is going to give us 7 remainder 4. Let's write that down. In 81, we divide by 11, it's going to give us 7 remainder 4, because 77 plus 4 is 81. So we take the 4 back to the table. Then 9 times 10 is 90. Of course, 11 can go in 88, 8 times. So in 90, there will be a remainder of 2. Then we take this 10 times 1, 10, 10 times 5, 50. 11 can go 4 times, we have 6 remaining. 10 times 9, 90. 11 can go in 88. So we have 2 remaining. 10 times 10, 100. 11 can go in 99, 9 times. So we have a remainder of 1. Now, we are through with the table. Now that we have completed the table, we are going to answer the questions below using the table that we have completed. Now, the question says, use the table to evaluate 9 times 5, then times 10 times 10. So we have, in the first bracket, we have 9 times 5. Then times, the second bracket is 10 times 10. Now, if you look at the first bracket, let's look at 9 times 5. 9 times 5, will come down here is 1. 9 times 5 from the table is 1. So here we have 1. Then times 10 times 10 from the table here. 10 times 10 will give us 1 again. 10 times 10 is 1. So here we have, now we have 1 times 1. 1 times 1 is 1. So that will be our final answer. So our answer to this particular question is 1. Now that's it. That's I. Let's go to II. Find the truth set of 10 times m equals 2. So we want to look at 10 times m equals 2. So we have to find the value of m. Now from the table, what do you multiply 10 with to give you 2? Look at where we have 2. 10. If we follow this line, we see 2 here. So 10 times 9 is 2. So we write but 10 times 9 from the table is 2. So what does that mean? It means that our m is 9. But because we are looking for the truth set, so this 9 will be inside a curly bracket to represent a set. A set. So this is what we have. 9. So this is what we have. All right. Now the next one, we are asked to find, that is the next one, let's call that III. Let's call it III. They said if a number multiplies itself, it will result to 4. So we'll go to the table and see where a number multiplies itself and the product gives 4. A number, let's say 1 times 1, it does not result to 4. 5 times 5 gives us 3, so and it's not 5. Let's go to 9. 9 times 9 gives us 4. Beautiful. Let's try 10. 10 times 10 gives us 1. So we take 9. We now say but from the table, 9 times 9 gives us 4. Therefore, n is the set containing an element 9. So this is what we have for this. So we've been able to show the solution to all of these problems. So this is how we handle modular arithmetic that requires the use of table. Hope this is clear enough. We are going to proceed now to see a second problem that also requires the use of table. We're going to see how that can be handled. Let's proceed to the next question. So we want to find the value of A. And as we have marked it here, we can see that 3 plus 2 equals A. Now, but we cannot say but in mode 6, 3 plus 2 equals 5. So if 3 plus 2 equals 5, therefore, means that A equals 5, because A is the result that we get when we add 3 and 2 together. The result we get is what we call A. And from here, we can see that A is actually 5. Now, this is the I. Let's look at the II. The II, we are looking for the value of B. We are looking for the value of B. And from this second table, this is where we have B. The second table is the table of multiplication. And this B is the product of 2 and 4. It's the product of 2 and 4. So we'll write that 2 times 4 is called B. 2 times 4 is called B. You can say but in the mode 6 table, in the mode 6 table, 2 times 4 is actually 2. No, 2 times 4 is 8, and if you divide 8 by 6, the remainder is 2. What does it tell us about B? Therefore, the value of B is 2. So we've seen that the value of B is 2, and the value of A is 5. So we move on now to look at the evaluation of the third part, where we are asked to evaluate 4 plus bracket 3 times 2. We look at that. That is the III. That part, we are asked to evaluate 4 plus, open bracket, 3 times 2. So this will give us, if you look at 3 times 2, let's go to the table of multiplication. 3 times 2 gives us 0. So this is 4 plus 0. And look at 4 plus 0, it gives us 4. All right. So with that, let's move on to the last question there. So for IV, we are told that 5 plus, in brackets, M times 3 equals 2. So that is, when we add something to 5, we are going to get 2. Now, let's go to the table of addition and see where do we have 2 when we add something to 5. Look at it, 5 plus something gives us 2 here. Look at 2. That is 5 plus 3 gives us 2. 5 plus 3 gives us 2. So we say here that it means that M times 3, if we look at it, 5 plus 3 gives us 2. So the whole of this represents 3. Represent 3. So we proceed now. M times 3 gives us 3. M something times 3 will give us 3. This is where we have, let's go and mark where we have 3. We have 3 here. We have 3 here. And we have, Okay, we say something times 3 gives us 3. So this is where it happens. So I've marked where it happens. Something times 3 gives us 3. So now, if you look at this place, look at what happens here. 3 times 3 gives us 3. So here from table, 3 times 3 gives us 3. All right. Now, again, look at this. Is it only 3 times 3? Look at this also. We can also see something times 3. Look at this. This we also produce. So 1 times 3 is 3. We have also seen from table that 1 times 3 is 3. Again, look at another one here. This is it. So this 1 times 3 gives us this 3 here. So we also see that 5 times 3 gives us 3. So what does it tell us about m? Therefore, m is either 1, 3, or 5. These are the values of m. So this is your classwork. Based on what we have done, you are asked to construct a table for multiplication in modulo 7. Modulo 7. You can correct this. This is modulo. This is modulo 7. On this set, use the table to solve the following equations. M times m equals 2. So you're going to find the value of m. Then the second one is n times bracket n times 6 equals 3. What is the value of n? Just pause the video. Take your time to solve this problem. When you are done, proceed with the video. In the next part of the video, I provide solution to this question. Use the solution to assess your work and see how far you are making progress. Let's proceed now. If you are done solving, to see the solution. So let's look at correction to the classwork. Now we are asked to construct a table for multiplication in modulo 7 on the set 2, 3, 5, 6. So we are using this, and we are doing this multiplication on modulo 7. Now let's look at what we'll get here. Let's fill up this. 2 times 2 is 4. 4 is smaller than 7, we write. 2 times 3 is 6. Of course, we can return this. 2 times 5 is 10. If you divide by 7, you have 1 remainder, 3. 2 times 6 is 12. If you divide by 7, your remainder will be 5. 3 times 2 is 6. 3 times 3 is 9. In modulo 7, 9 is 2. That is, if you divide 9 by 7, the remainder is 2. 3 times 5 is 15. Divide by 7, the remainder will be 1. 3 times 6, 18. Divide by 7, the remainder will be 4. 5 times 2, 10. If you divide by 7, the remainder will be 3. 5 times 3, 15, divided by 7, the remainder will be 1. 5 times 5, 25. If you divide by 7, 7 can go in 21, so we have remainder 4 here. 5 times 6 is 30, 7 can go in 28, so we have remainder 2 here. 6 times 2, 12, so 7 in 12, we have remainder 5. 6 times 3, 18, 7 in 18, we have remainder 4. 6 times 5, 30, 7 in 30, we have remainder 2. 6 times 6, 36, 7 can go in 35, so in 36, we have remainder 1. So now let's use this table to answer this question here. So they said if a number multiplies itself, the result is going to be 2. So we'll look at from the table. So we go here, we say from table, let's look at the number that let's look at where we'll get 2. We have 2, that means 3 times 3. 3 times 3 is 2. Again, look at where we have 2, but this is 6 times 5. We have 2 here. This is 5 times 6. So we have 2. We have 2 here. We have 2 here. We have 2 here. And we have 2 here. So it's only this one that satisfies the condition that gives us 3 times 3. So here, our m, therefore, our m is equal to 2. Our m is 3, rather, because 3 times 3 is 2. So our m is 3. Let's go to the next question. Then they said, if you multiply a number n by n times 6, you get 3. Now, let's handle this. That is, if you look at, let's see, we are looking at numbers in this bracket. If I multiply a number by another number, it gives me 3. All right? If I multiply n by something, if I multiply n by something, it gives me 3. All right? So let's go and see how we can handle this. Now, look at what this question is saying. Look at this quantity here. Look at the quantity here. They are not the same, but the product of this and the product of this will result to 3. Now, let's see where our value from multiplying 2 elements of modulo 7 numbers. If we multiply, we get 3. See where we have 3. We have 3 here. Let's pick it up. We have 3 here. Okay. Now, here we have 2 times 5 from the table. Let's say from okay. Let's rub off this. Okay. From the table, we see that 2 times 5 gives us 3. And we also notice again that 5 times 2 5 times 2 gives us 3. Now, with this in mind, let us go and do something. Now, what does it mean? Now, we will try let n equals 2, for example. Let n equals 2. We are going to test it. So we want to test 2 times 2 times 6. Will it result to 3? If it result to 3, that means n equals 2 will be correct. So this will give us 2 times, what is 2 times, okay. What is 2 times 6 from the table? 2 times 6 is 5. So this is what we have here. And what is 2 times 5? 2 times 5 is 3. So we conclude that therefore n equals 2. We go again. Let n equals 5. Let n equals 5 because 5, a combination of 5 and 2 results to 3. We are looking at those things that result to 3 here. So let n equals 5. We also try it again. If n is 5, we have 5 times bracket 5 times 6. Oh, so we want to see whether we'll get 3 here. This is 5 times, what is 5 times 6 here? 5 times 6 is 2. 5 times 6 is 2. And what is 5 times 2? 5 times 2 is 3. Our final result is 3. Therefore, n equals 5. So we conclude, hence, n equals 2 or 5. So those were the two values of n. So we've been able to do justice to this classwork, and this is where we will end today's tutorial, and that's also where we are going to end modular arithmetic. In our next class, we are going to proceed to another topic. Why not check our channel to see the next video that we are going to soon release. Thank you for being with us. We appreciate your endurance. If you find value in this video, click like, share this video, click on the notification bell so that each time we publish a new video, you will be able to get it. If you have not subscribed, please do so that we become part of our family. It's our intention, our desire to make this video reach many students. Help us to achieve this goal. Thank you very much. See you in our next tutorial class. This is Math Minders Academy. Goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught in the spell of the cosmic night, where fantasies bloom in the pale moonlight. We'll let go of all that we know and dance in the stardust's gentle flow. Dancing